Hello, everybody. This is our CSC 413 final project. We decided to do a class schedule and walking path database. My name is Will Holen, and my teammates are Greg Gergen and Christian Norris. Our motivation is that students at UNL often need to move across campus quickly, but sometimes it's difficult to estimate how long it'll take to travel between buildings or understanding where exactly they need to be at certain times of the day. Our goal was to create a database that stores multiple building locations across campus and every student's schedules, and then using this information, provide the users with different types of useful information that could help them plan out their days. For our database design, we have several tables. We have a student table, schedule table, course table, building table, and a path table. So for our student table, we have an ID and their name, major, and then the residence building that they are living in. For the schedule table, we have an ID, a student ID, a course ID, and then the day of the week that course is on for their schedule. Then for our course table, we have an ID, name, the building ID that it is located in, the room number, and then the start and end times. And then for our building table, we have an ID, an occupancy number, the building name, and then the X and Y constraints for or a geographic shape that we will have on the graph. And then finally, we have a path table that has an ID, the start building ID, and then the end building ID. And then we have the distance in meters, which is has been calculated using Manhattan city block distance. And then finally, we have our walk time in minutes. So then here's our schemas for each table. Pretty simple, like compared to last slide. Our bolded attributes are our primary keys, and then our italicized attributes are foreign keys that are linked to other tables.
My name is Gray, and we'll be going over the data sources in our project. So for student, we used Husker football players and mascots just as examples. And for building, we selected buildings on the UNL campus and created a constraint table to represent the buildings as objects on our map, and then used a map of campus and then scaled the building location visually. So just picking points on the XY coordinate plane where those buildings would best be located. And for the course, we drafted courses with varying starts and building locations. And for the schedule, we assigned students to 3 courses randomly. For the path, used an R script to generate all possible walking paths between buildings. Assumed 1 unit on a map is 100 meters, and assumed walking speed to be 100 meters per minute. Now for our implementation of the tables. Here's our student table. You see with the football players and the mascots and our major, and then the residence building hall they're part of. And for our building table, we got Hamilton, Avery, Oldfather, LPH, Hewitt, Abel, and Smith. And the occupancy of those buildings, and then the constraints. And then here is a visualization of that building, of the buildings you see up top. Up top, that is Smith, and then over to the right, that is Abel and Hewitt, and then the other buildings off there to the left. And then here's the course table, the name of the courses, the building ID in which the courses are located at, then the room number and start time, and then end time is cut off to the right. And then here's our schedule table with our student ID assigned to the courses and the day of the week. And then here's our path table with the starting building ID, the end building ID, distance in meters, and the walk time.
Functions that we did. Our first one is one that's like, I guess, like say you have an early morning class and you don't want to walk too far, or you want to see which classes are far away from you. you'd be able to use this one to see like what classes or what buildings rather are at least so far away, or you could easily flip it around and make it which buildings are within a certain radius of either of the residence halls. And I will pull that up. All right, here is the program, kind of all these pieces together. Well, SQL crashed. Then we have the function saying how far is each class from each residence hall. Basically, like theoretically, if like someone's like, I don't want to take a class that's this far away at this time, they could use this to see like how far away each building is from a residence hall, or say I only want ones outside or inside of a range of either the residence halls. So that this function would look like this. And then it'll give this. I have it set to 750 because we did change our distances. Then we have our next function, which is how many people are in a building at a given time. At a different time, if we had like a lot of students, we could just put like count and see how many students. But right now we just have it listing showing what students are in what uh, building at a given time. And that this looks like this. It's just putting a random time like 10:50, which gives nobody. And then if we set it to just like 1000, we get these four results showing that we have students 1, 2, 3, and 4 in this class at this time. Then lastly, we have like given a point, does that fall onto a building? That I have right here. It's just this simple program or query right here. And that point gives Avery Hall currently. And then if you were to give another one, it would give a different hall potentially.
All right, so for the conclusions and future work, we built a spatial database containing building data, student schedules, and paths between buildings. We implemented queries that allow users to estimate travel time between any two UNL buildings and then determine a student's location at a specific time using schedules and paths. Future work would include real-time data, more advanced student movement, and more data for each table. Thanks for listening.